you all on India's largest online e-learning platform, that is Gradeup, guys. So I think all of you know this particular series, guys. In this particular series, we will discuss about the problems for your BARC examination and ISRO for and as well as AAI, right? So guys, today our topic is structure analysis and RCC. Definitely you will enjoy this particular session because I have put different kind of questions over here. मैंने structure और RCC के questions कुछ different put करे हैं बच्चों, and definitely you will enjoy it. Okay, so just let me know I'm perfectly audible as well as visible to all of you or not. Just write in the comment box and please hit the like button as well as share this session to maximum students so that they get benefit from this particular session, right? So just hit the like button and let me know, guys, I'm perfectly audible or visible, right? जल्दी से चैट बॉक्स में लिखेंगे बच्चों, ऑडियो वीडियो क्लियर है क्या आप सभी को? Audio and video is clear to all of you or not? Just let me know. Okay, perfect. So guys, let's begin this session. Let me introduce myself. My name is Krishna. I had 8 year teaching experience in this particular field. और बच्चों मैंने मेरा मास्टर्स IIT रुड़की से कंप्लीट करा है. I mentored almost 14,000 plus students for these examination, and my area of expertise is environmental engineering, structure analysis, RCC, and engineering mechanics. Right. So I will show you the questions, guys, and we will solve the problem simultaneously. And just check it whether you are able to solve such type of problem or not. Okay. So I will tell you also the short tricks and how we can eliminate the options. हम कैसे ऑप्शन में eliminate कर सकते हैं बच्चों, ये भी हम सीखेंगे, right? So this is the first question in front of you, and it is a very simple question. Just see this one and let me know whether you are able to solve this one or not. Just you have to use your mind. बस थोड़ा सा बच्चों दिमाग लगाना है, you will get the answer. Okay? So just tell me the answer in the comment box, all of you. This is the question number 1. You have to just find the SFD and BMD for this particular structure. SFD और BMD बताना है बच्चों इस particular structure के लिए क्या होगा, right? Tell me, guys, quickly. SFD and BMD for this particular structure. You can eliminate the option over here. आप ऑप्शन को एलिमिनेट भी कर सकते हो बच्चों, है ना? A. मिलन बोल रहे हैं सर ए होगा. ओके. सो लेट मी टेल यू गाइस हाउ वी कैन प्रेडिक्ट इट. वी नो दैट, हम ये जानते हैं बच्चों, वी नो दैट इफ लोडिंग इज टू बी देयर इन द डाउनवर्ड डायरेक्शन देन द टॉप फाइबर इज इन ऑलवेज कंप्रेशन, है ना? देन दैट पर्टिकुलर टॉप फाइबर इज इन कंप्रेशन एंड द बॉटम फाइबर इज इन टेंशन. सो व्हाट हैपन, this particular moment is representing the sagging moment. ये क्या represent कर रहा है बच्चों? It is representing the sagging moment. And in option number C and option number D, they are representing the moment as a negative moment, which is a hogging one. So we can remove these options directly without writing anything. है ना? We can remove this particular option directly without writing anything. Now let's understand option number A and option number B. है ना जी? Option A and option B. How we can predict which one is the correct? Now we know that, guys, if 5 kilonewton is there, it is in downward direction as well as this one is also in downward direction. So we have support reaction over here like 5 kilonewton and 5 kilonewton because your loading is symmetric as well as structure is symmetric, right? So VA is equal to how much? 5 kilonewton. Similarly, guys, VB is equal to how much? It is also 5 kilonewton, right? Now what we have to do? We have to take a section over here. यहाँ पे हमें एक section लेना चाहिए, right? Now if we take the section over here and if we find the shear force at this particular section, that is your plus 5 kilonewton, right? So can I say that, guys, A option is correct because in option B you can see here they have represented the shear force as a negative, right? Minus 5. So which one is wrong? And we can say that, guys, A is the correct answer. कौन सा ऑप्शन सही होगा भाई? A, क्योंकि हम जानते हैं whenever we are considering the section and whatever shear force is there on the left of the section and it is in upward direction or right of the section in the downward direction, then we have to consider as a positive. कैसा कंसिडर करना है बच्चों? पॉजिटिव कंसिडर करना है. सो वी कैन एलिमिनेट द ऑप्शन सी, डी एंड बी. सो ए इज द करेक्ट आंसर. ए सही आंसर होगा बच्चों. नेक्स्ट क्वेश्चन. Next question in front of you guys. Tell me or choose the correct combination where all the members carry zero force. You have to just find the zero force member over here. है ना? यहां पे बच्चों आप लोगों को बताना है जीरो फोर्स मेंबर कौन कौन से होंगे. Choose the correct combination where all the members carry zero force. Just write in the comment box all of you. है ना? सभी लोग कमेंट बॉक्स में अपना आंसर पुट करेंगे बच्चों. Just put your answer in the comment box. You have to just choose the correct combination for the zero force member. है ना? जीरो फोर्स मेंबर के कॉम्बिनेशन बताइए बच्चों. You have to just find that particular joint at which you may get the zero force. I think it is a very simple problem and all of you are able to solve this one. You can see here guys, this is your joint which is M, in which two are collinear and one is non-collinear. You can make it zero. Simple. Similarly guys, after removing this MJ member, we can consider joint J again, in which two member are collinear and this one is non-collinear. We can make it zero. Okay sir. Similarly guys, we can consider joint G, in which GI and GA are collinear in nature and GB is non-collinear. You can make it zero again. Again we can consider joint B, two collinear, one is non-collinear. Again it is zero. Now guys, at joint I we have only three members in which force is to be there, like MI and GI and IC, because we know that IJ and IB are null force member. So we can remove it for the analysis purpose. But in the actual condition, you are not able to remove such type of member because it is also required for the stability part. ये stability के लिए भी required होता है बच्चों, ये ध्यान रखना है. Now we can consider joint I. We can consider joint I in which these two member are collinear and this one is non-collinear. You can make it zero again. है ना जी? ये zero हो गया. Now again consider joint H. HF and HL are collinear and HE is non-collinear. Make it zero. Similarly guys, EF and ED are collinear and this one is non-collinear. Make it zero. Okay sir. Now just choose the correct option over here. यहाँ पे ऑप्शन सही देख लेते हैं बच्चों कौन कौन से होंगे. MJ होगा. Yes sir, MJ is correct. IJ is correct. BG is correct. BI is also correct. EL, yes, EL is correct. And EH is to be correct. So it means C is the correct answer. कौन सा सही हो गया जी? C is the correct answer, right? Now let's move to the next question. अगले क्वेश्चन में बढ़ते हैं बच्चों और अगले क्वेश्चन में हम देखते हैं कैसे सॉल्व होगा. A beam AB is fixed at both the ends. एक बीम है बच्चों AB जो कि दोनों एंड पे कैसा है भाई? फिक्स्ड है. At both the ends they are fixed in nature. This one is also fixed and this one is also fixed, right? Both the ends are fixed over here and a UDL is to be placed on the entire span. एक UDL है बच्चों जो कि पूरे स्पान पे लोडेड है, right? So this one is what? W per meter, right? It is given to us. Due to some constructional defect, the end B now reduced to a simply support. It means you have to just convert this particular end. This one is A. Let us consider this one is A and this one is B. You have to just convert this particular end as a simply support. इसको simply support की तरह consider कर लो बच्चों. क्या होगा फिर? देखते हैं. Now we have to make this particular end as a fixed and this one is as a simply support. Okay sir. And we have to again load this particular structure with a UDL. UDL से बच्चों उसको load करना है, right? Now let's understand. Due to some constructional defect, the end B now reduced to a simply support. The percentage increase bending moment at A. You have to just tell me guys by how much value your bending moment is to be increased at support A. A पर कितने से increase होगा? है ना, ये हमें बताना है बच्चों. नाउ इट इज वेरी वेरी सिंपल, जस्ट सेटल दिस पर्टिकुलर जॉइंट बी, है ना. अगर बच्चों यहां पे हमें क्या बोला गया है कि अगर, सॉरी नॉट सेटलमेंट, at this particular joint we have to consider the hinge support, right? That is your simply support. Now we know that guys, due to fixed and we have a moment over here which is WL square by 12, and this one is also WL square by 12, right? Now we know that guys, at this particular joint there is no external movement should be present, है ना. यहां पर external movement कुछ भी present नहीं होना चाहिए. Now can I say that guys, in the initial condition WL square by 12 is to be present over here. Similarly, in the initial condition the WL square by 12 is to be present over here, है ना, यहां पे present होगा. Now we know that we have to make this particular end free from the bending moment. So can we say that guys, we have to apply a moment at this particular joint which have same magnitude but opposite in nature. यही करना होगा. So let us apply a moment over here which is in anti-clockwise direction, whose magnitude is WL square by 12. Now we know that guys, the far end is fixed, so we have to carry over the half of the magnitude of this moment and the direction will remain same. It means it is in anti-clockwise direction and it should be WL square by 24, right? Now just add both the moments, you will get the result. So at this particular joint it is positive and this one is negative. You can make it 0 and you can see here guys, this one is negative which is WL square by 12, and again you have to add this particular value which is WL square by 24 over here. So can I say that by 50% your movement will get increase. कितने परसेंट से इंक्रीज हो गया? 50% से. कितने परसेंट से इंक्रीज हो गया? 50% से. You can see here guys, this is the initial value and what is your final value? This is your final value, and you can see here this is the amount by which your movement get increase at joint A, है ना. If you divide this particular value WL square by 24 divided by WL square by 12 multiply by 100, you will get the answer which is 50%. कितना होगा बच्चों? 50%. Simple. So this is the B. B is the answer, right? Next question guys. Due to network issue not able to watch. Okay Milind. Good evening Varsha. Good evening. आते जाओ बच्चों. चलिए. Now tell me, for this particular question guys, the structure shown in figure is stable. यहां पे जो स्ट्रक्चर आपको शो करा गया है बच्चों, at which condition it is stable? At which condition it is to be stable over here? किस कंडीशन में बच्चों ये स्टेबल होगा? At which particular condition it is to be stable over here? किस कंडीशन पे स्टेबल होगा? You have to just find the relation between x and y. इनके बीच में रिलेशन फाइंड करना है. जल्दी जल्दी आंसर देंगे बच्चा लोग. कमेंट बॉक्स में अपने अपने आंसर छोड़िए फटाफट फटाफट, है ना जी, और बताएंगे इसका आंसर क्या होगा. कैप्टन सेज ए होगा. ओके, एनी अदर स्टूडेंट who know the answer for this question? You have to just find the relation between the x and y so that this particular structure is stable. ये structure stable होना चाहिए जी. And just share this particular session guys. इसको शेयर करिए एंड लाइक करिए बच्चों सेशन को. आई थिंक कैप्टन ने आंसर दिया है, अजय ने आंसर दिया है. दैट इज योर ए. ओके, वी विल चेक इट गाइस, वी विल चेक इट. वी नो दैट गाइस, in the structure each and every joint should be in stable condition, right? So it means whatever movement is coming at this particular joint, that should be same as the moment which is coming at this particular joint from this particular portion, which is your right portion, and this one is left portion, right? And it is a very very simple thing. Now let me tell you one thing more guys. You can see here, let us make one end as a fixed and other as hinge. मान लेते हैं एक एंड फिक्स्ड है और एक एंड हिंज है. And let us consider guys, a UDL is to be placed over here. Now we know that guys, what will be the moment or what will be the fixed end moment at the fixed end as well as your hinge end. it is equal to how much? It should be equal to 0. At this particular end, it is equal to WL square by 12 minus WL square by 24, right? इसको add करोगे, how much you will get? Finally, that is minus WL square by 8. So can I say that, guys? क्या मैं बोल सकता हूं बच्चों, if we have one end as a hinge and other as a fixed, so we have fixed end moment which is equal to 0 at hinge end and WL square by 8 at the fixed end, right? Or at the rigid joint. So guys, again we can apply this particular concept over here. यहां पर वही concept तो हम लगा सकते हैं ना यार? नहीं लगा सकते क्या? बिल्कुल लगा सकते हैं. So you can see here, guys, at this particular joint there should not be any moment, but we have moment over here. यहां पर तो moment होना चाहिए ना भाई, बोलो यार. यहां पे तो आपके पास moment होगा. And what will be the value of this particular moment? इस moment का value कितना होगा? WH square by 8. Now what is the value of W? It is 2W. ये कितना है बच्चों? 2W है. What is the value of L? It is X. So X square divided by 8. Similarly, guys, we have moment at this particular joint also from your right portion. So right portion से moment कितना आएगा? From your right portion, what will be the moment over here? क्या मैं बोल सकता हूं बच्चों, it is equal to W y square by 8, right? And both should be equal. ये दोनों क्या होना चाहिए? Equal. Why? To balance this particular joint, you have to make both the joint or both the moments as a same of magnitude, right? So guys, we have to make it equal and just cancel it out. Just cancel this one also. You will get a relation which is root 2x is equal to y. सर बफरिंग हो रहा है, एक मिनट बच्चों, वेट अ मिनट, लेट मी चेक इट अगेन. जिससे वॉइस और क्वेश्चन क्लियर नहीं आ रहा है. ऑल ऑफ यू आर फेसिंग सेम प्रॉब्लम, जस्ट लेट मी नो गाइस. वर्षा से इससे डी होगा. All of you are facing same problem, that is buffering problem और voice and questions are not, दोनों क्लियर नहीं हो रहा है. क्या ऐसा कुछ है बच्चों? आई थिंक ये चीज नहीं हो रही है. आई थिंक ऐसा हो रहा है क्या बच्चों? जस्ट लेट मी नो. नितांत, आई एम गुड. 10 बजे के बाद डायरेक्ट आज आपको लाइव देख रहा हूँ. ओके, जस्ट लेट मी नो गाइज. आई एम परफेक्टली ऑडिबल एज वेल एज विजिबल. ऑल गुड ना? ठीक है, ऑल गुड है, कोई दिक्कत नहीं है. रॉक इंजीनियर, यू कैन जस्ट रिफ्रेश योर वीडियो. इट मे बी पॉसिबल देयर इज सम नेटवर्क इश्यू, तो हो सकता है बच्चे आपको कोई दिक्कत हो रही हो, तो एक बार रिफ्रेश कर लीजिए. फाइन सर, ओके गुड. सो विच वन इज द करेक्ट आंसर गाइस? विच वन इज द करेक्ट आंसर? डी इज द करेक्ट आंसर. यहाँ पे आंसर क्या होगा बच्चों? डी इज द करेक्ट आंसर, राइट? चलिए जी, नेक्स्ट क्वेश्चन पे बढ़ते आगे. The ILD for moment at section C will be, this particular section is C over here. Just you have to find the moment at this particular section. ILD for moment at this particular section. बताइए बच्चों क्या होगा यार? ILD for moment at section C will be equal to how much? Or which particular option is correct over here? The answer is sir D होगा. Anyone? Any other student guys जिसको आंसर पता हो? ILD बताना है बच्चों, बड़ा सिंपल है. And just you have to use the Mueller-Breslau principle because we know that this particular structure is what? Determinate one. ये कैसा है बच्चों? Determinate structure है. And we can use the Mueller-Breslau principle over here. है ना? Mueller-Breslau principle use कर सकते हैं. Tell me guys. Vasha says sir B होगा. Very good guys. So let's check it. Let us suppose this is our section C. At section C, we have to make a hinge over here because we have to release the moment which is present at section C as per the Mueller-Breslau principle. That's why guys, I have applied a hinge over here. Now we know that guys, this particular structure is determinate. So whatever ILD is to be there, it is always a linear one. है ना? इसमें वेरिएशन कैसा होगा? इट इज ऑलवेज लीनियर वन. दैट्स व्हाई गाइस, we have to take care while drawing the ILD over here. यहाँ पे हमें conditions को ध्यान रखना है. Now we know that guys, if we release this particular moment at this particular section C, so we have to apply the unit rotation, which is theta 1 and theta 2 in this way. But we know that guys, if we apply theta 1, then this particular portion will become curved. ये कैसा बन जाएगा यार? ये curved बन जाएगा, and it is practically not possible. ये practically possible ही नहीं कि curved होना चाहिए, क्योंकि ये determinate structure है. So we can say that guys, our theta 1 is equal to how much? It should be equal to 0. But what about theta 2? It should be equal to 1. Whatever unit rotation is to be there, it is taken by your theta 2 only. So if you deflect this particular structure, it is to be like this. ऐसा हो जाएगा. And you can see guys, this rotation is theta is equal to how much? 1. And this value is negative. Now we know that guys, this distance is B and this one is A. Now if we take the tan theta or theta is equal to 1, and let us consider this particular y as a depth. So y by b. So y is equal to how much? It is equal to b. So guys, this one is b. So b is the correct answer. Okay, Nitan, previous वाले का आंसर था. ठीक है, ठीक है. Okay, okay. Now I think you are able to understand how to draw the ILD for moment at section C. और बच्चों कौन सा ऑप्शन होगा यार? B is the correct answer. B सही है. नेक्स्ट क्वेश्चन, बड़ा मजेदार क्वेश्चन है ये, और देखते हैं यार ये वाला क्वेश्चन कितने बच्चे सही तरीके से सॉल्व कर पाते हैं. राइट, ये वाला क्वेश्चन कितने बच्चे सही तरीके से और मजेदार तरीके से सॉल्व कर पाते हैं, बिकॉज इट इज अ वेरी गुड क्वेश्चन. द वैल्यू ऑफ ऑर्डिनेट एट द क्वार्टर स्पान ऑफ द ILD फॉर मिड स्पान बेंडिंग मोमेंट ऑफ अ सिंपली सपोर्टेड बीम is 0.5. ये हमें गिवन है. And if the span of beam is doubled, then what will be the ordinate at the mid span of the ILD? Tell me guys. This is a very good question. It will twist your brain. आपका दिमाग को घुमाने वाला क्वेश्चन है बच्चों. Just try to solve by yourself. एक बार आप खुद कोशिश करें फटाफट. Just try it guys, just try it. It is a very good question. ऐसे क्वेश्चन आपको मिल सकते हैं एग्जाम में, right? The value of ordinates at the quarter span of the influence line diagram for mid span bending moment of a simply supported beam is 0.5 meter, right? So first of all, you have to draw the ILD over here for the mid span bending moment for the simply supported beam, right? आप एक simply supported beam लीजिए बच्चों and just try to make the ILD for the mid span bending moment first. So we know that guys, what will be the ILD for mid span bending moment? First of all, you have to make a hinge over here and just try to apply the unit rotation. Unit rotation apply करिए बच्चों. This is your theta 1 plus theta 2 is equal to how much? 1. And you know that guys, the deflected shape is to be like this, and this particular ordinate is equal to how much? ये पता है बच्चों, ये कितना होता है? This particular ordinate, which is y is equal to how much? To calculate the y, you have to understand guys, this one is theta 1 and this one is theta 2, and we know that this particular distance is equal to how much? It is L by 2. ये कितना होगा जी? ये L by 2 है, and this one is also how much? L by 2, right? Now we know that guys, generally this ordinate is to be like AB by L. ये होता है ना बच्चों. तो A की वैल्यू कितनी है? What is the value of A over here? It is L by 2. And what is the value of B? It is also L by 2. So L by 2 cross L by 2 divided by L, you can make it as L by 4, right? So this is the mid span ordinate. But as per the question, they have given the value of ordinate at the quarter span of the ILD for mid span bending moment. So this is the ILD for mid span bending moment. ILD for mid span bending moment. Mid span bending moment. ये mid span bending moment का ILD है. Now we know that guys, if we mark a distance which is L by 4, यहाँ पे अगर एक distance mark करी जाए, that is your L by 4, so we can find the ordinate over here which is our y dash. right? Now we know that, guys, at L by 2 distance, we have a ordinate of L by 4. If we have a distance of L by 4, then what will be the ordinate, which is y dash? So just write y dash is equal to L by 4 into L by 4 divided by L by 2, right? You can cancel it, okay? And we can cancel this one is also, which is L by 8. Simple. Now we know that, guys, this particular value is equal to how much? It is equal to 0.5 meter. So what will be the span length? It is equal to 4 meter. So this particular span is nothing as 4 meter. पहला चीज तो ये समझ में आ गया सर, this particular span is equal to how much? 4 meter. यहां से लेके यहां तक का डिस्टेंस कितना है बच्चों? That is equal to 4 meter. Okay, sir. Now, as per the question, if the span of beam is double, now we have to double this particular span. अभी 4 मीटर था ना बच्चों, अब कितना बना दीजिए? 8 मीटर बना दीजिए. Now our span is 8 meter over here. Okay, it is double as compared to the previous one. Now what will be the ordinate at the mid span of the influence line? Now as per the question, you have to just find the mid span bending moment ILD over here first, as well as you have to find the ordinate of mid span bending moment at the mid span only, right? Mid span bending moment ILD का ordinate कहाँ निकालना है? Mid span पे निकालना है. And let us consider this one is y double dash and is equal to how much? L by 4 again. It is equal to how much? L by 4 again. So guys, we know that what is the value of L over here? It is equal to 8 divided by 4, and this is our y double dash. So it is equal to how much? 2 meter. कितना आया? 2 meter आएगा बच्चों. If the span of beam is doubled, what will be the ordinate at the mid span of the influence line? Influence line पे कितना होगा जी ordinate? ये बताना है mid span पे. So 2 meter is the correct answer. A is the correct answer, not B. वर्षा B नहीं होगा बच्चे, A आंसर होगा सही. ठीक है, चलिए नेक्स्ट क्वेश्चन आगे बढ़ते हैं. The influence line for the vertical reaction at support A. At support A. The influence line diagram for vertical reaction at support A. ये बताना है बच्चों, जल्दी से बताएंगे इसका आंसर क्या होगा. Try it guys, try it quickly. We know that what is Mueller-Breslau principle. हम जानते हैं ना Mueller-Breslau principle क्या होता है, and we can apply it. Just we have to release the reaction which is present at support A. हमें सबसे पहले reaction support A को रिलीज करना होगा by making it as a guided roller. यहां पे बच्चों इसको हमें कैसा बनाना पड़ेगा? This should be your guided roller over here. Guided roller. It means we have released the reaction which is V. यहां पर आपके पास रिएक्शन कौन कौन सा है बच्चा? VA and MA as well as HA, right? Similarly, we have VB reaction as well as VC reaction. But we know that by using Mueller-Breslau principle, we have to release this particular support reaction, that is your VA. VA को release कर दो यार, and give unit displacement. It means delta is equal to how much? 1. And the deflected shape of structure is your ILD for VA. बताओ यार, ये हो जाएगा, right? And this particular portion is to be positive over here, and this one is negative. So tell me guys, which one is the correct answer? A, B, C, D. कौन सा है? A is the correct answer. This one is positive and this one is negative. समझ में आया बच्चों? बहुत शानदार जी. आगे बढ़े. Next question guys. Yes, yes नितांत. Vertical guided roller को देख के ही रिलीज करना है. Okay. Okay. Next question guys. In the beam shown in figure, if the displacement at C due to W at B is 5 mm, then displacement at B due to a load of 0.2 W at C. अब बताइए इसमें से कौन सा ऑप्शन सही है? And it is totally based upon Beatty's law. Beatty's law पे बेस्ड क्वेश्चन है बच्चों, है ना? It is totally based upon Beatty's law. Beatty's law पे बेस्ड है, and you have to consider the virtual work over here. Please hit the like button as well as share this session guys. आप इसे शेयर भी करें ताकि काफी बच्चे जुड़ सकें और उन्हें फायदा हो. Okay? Tell me guys. This is the first condition which is given to us. It means If W is to be put at the joint D, then you may find the displacement at C which is equal to 5 mm. ये बोला है जी, देख लेते हैं क्या बोला है इन्होंने. In the beam shown in figure, if the displacement at C due to W at B is 5 mm. Yes, they have mentioned this particular displacement as a 5 mm. ये दिया हुआ है बच्चों 5 mm. Now, as per the statement, then the displacement at B due to a load of 0.2 W at C. यार यहां पे आपके पास स्ट्रक्चर है, you have a structure over here. This joint is B, this joint is C. Now let us consider if we apply a load which is equal to 0.2 W. मान लीजिए 0.2 W लगाया. Now just we have to find the displacement at joint B. So guys, again you can make a deflected shape first and mark the value which is delta B star, right? And we know that what is the virtual work done by your W force as well as your 0.2 W. So we can write it W into delta B star is equal to 0.2 W into delta C star, right? So we know that guys, 0.2 W into how much? 5, and delta B star into W. Just cancel W to W, you will get the answer. WB star is equal to how much? It is 1 mm. कितना आ गया बच्चों? 1 mm. A is the correct answer. A सही हो गया? Very good आसिम. Very good. Very good. बहुत ही सिंपल क्वेश्चन था. नेक्स्ट क्वेश्चन, एंड इट इज अ वेरी गुड क्वेश्चन. मैं चाहूंगा कि सभी लोग इसका आंसर दें. मैं पहले इसको सॉल्व नहीं करूंगा बच्चों. जस्ट यू हैव टू सॉल्व दिस वन एंड टेल मी विच पर्टिकुलर ऑप्शन इज करेक्ट. बहुत ही अच्छा क्वेश्चन है. जस्ट रीड इट केयरफुली एंड टेल मी विच पर्टिकुलर ऑप्शन इज करेक्ट. इनमें से कौन सा ऑप्शन सही है? फटाफट कमेंट बॉक्स में सभी लोग छोड़ेंगे जी आंसर. Tell me guys, which one is the correct answer over here? बताएं बच्चों. If you know the concept of rigid joint and the hinge joint, then you can take the answer. अगर आपको hinge और rigid joint का concept पता है तो आंसर टिक हो जाएगा. वर्षा से इससे डी होगा, नितांत से इससे सी होगा, नितांत बोल रहे हैं सी होगा. ओके, एनी अदर स्टूडेंट जो बता सके बच्चों आंसर क्या होगा इसका? सभी बच्चे, जो भी बच्चे लाइव हैं, अपना आंसर पुट करें बच्चों कमेंट बॉक्स में, ताकि आप लोगों को फील हो कि हाँ आप लोगों को इतना कंसेप्ट क्लियर है. जल्दी से पुट करेंगे बच्चों. हिंज की कंडीशन ध्यान रखनी है. इफ यू नो द कंडीशन ऑफ हिंज देन यू कैन टेक द आंसर. दो बच्चों ने आंसर दिया है बच्चों, वर्षा, नितांत. वर्षा बोल रहे हैं सर डी होगा और नितांत बोल रहे हैं सर सी होगा. आसिम ने बोला है डी होगा. ऑल द मेंबर्स आर सब्जेक्टेड टू द मूवमेंट. अच्छा जी, और कोई स्टूडेंट जो आंसर दे सके इसका? और कोई स्टूडेंट जो आंसर दे सके? एनी वन ऑफ यू हु आर एबल टू सॉल्व दिस प्रॉब्लम? टेल मी गाइस. तीन ही बच्चों ने आंसर दिया अभी तक. चलो मैं बताता हूं बच्चों, कोई बात नहीं. लिसन, 4 identical beam AE, BE, CE and DE have been hinged at E. It means these members are connected at this particular hinge, right? Now the point C slip and rotate along with member EC. बाबू को फिक्स कर दिया था इसमें. हाँ जी, बिल्कुल बिल्कुल बिल्कुल. अब ध्यान सुनो. Now the point C gets slip over here. It means it is trying to settle over here, है ना? Point C settle हो गया. Now what happened guys? This particular joint can rotate freely about this particular E. Now tell me guys, we know that this particular joint is hinge. It will not change any angle for member DE, member EA or member BE because there is no connection between all these members directly, and whatever the effect of moment is to be there, it is not transfer on other members because it is hinge. क्यों? क्योंकि ये hinge है, इसलिए बच्चों. So we can say that At hinge joint, the moment is always equal to how much? It is always equal to 0. And definitely, if it is settled in this direction, then it will develop some moment at fixed end. इस पे जरूर डेवलप करेगा, but there is no effect on member BE, member AE and member ED. कोई इफेक्ट नहीं होगा जी, सिर्फ इफेक्ट कहां पे आएगा? C पे आएगा. So can I say that guys, you may have some moment which is MCE which is not equal to 0. अब बताओ यार, अब कौन सा ऑप्शन लग रहा है? Except at C, except at this particular joint, there is no movement on the members of the frame. It means B is the correct answer. B सही होगा बच्चों. आप लोग जो सोच रहे थे थोड़ा सा उससे अलग है. यहां पर आंसर है B. C पर ही सिर्फ मूवमेंट होगा. You may find the movement at the C only. Right? चलिए next question guys. Now the next question. Next question in front of you. The rise of a parabolic arch at quarter point is equal to how much? ये तो यार सभी लोग आंसर दे देंगे. I think all of you are able to give the answer for this question. The rise of a parabolic arch at the quarter point is equal to how much? सर मेरा रॉन्ग हो गया. कोई बात नहीं निदान, कोई बात नहीं, होता है यार. This is the last question from the structure analysis. Then we will start the RCC also. है ना? RCC भी स्टार्ट करेंगे फटाफट से और देखते हैं RCC में कितने बच्चे कितने क्वेश्चन को अच्छे से सॉल्व कर पाते हैं. Tell me guys, I think इसका आंसर तो सभी को पता होगा. The rise of a parabolic arch at the quarter point is equal to how much? This is your central rise, which is equal to how much? H. And this one is what? Your span, which is the horizontal distance between the support as a L. है ना जी? Now just we have to find the value of rise at a distance of L by 4. We have to just find this particular value y at a distance of L by 4. वर्षा से C होगा. वर्षा बोल रहे हैं बच्चे C होगा. अच्छा बाकी बच्चे क्या बोलते हैं? I think all of you know this particular equation, which is y is equal to 4hx divided by L square into L minus x. I think all of you know this particular equation, which is the equation of parabola. Asim bol rahe hain sir B hoga. Okay, we will check it guys. Now you can see here guys, this is our distance of a quarter point, which is x equal to how much? L by 4. You have to just put this particular value in this particular equation. है ना? इस इक्वेशन में पुट करना है. एंड दिस इज नथिंग एज गाइस, दिस इज योर इक्वेशन ऑफ पैराबोला. ये किसकी इक्वेशन है? इक्वेशन ऑफ पैराबोला. इक्वेशन ऑफ पैराबोला. ये पैराबोला का तो इक्वेशन है यार. सॉरी सर बी. ओके, सो लेट्स पुट दिस वैल्यू एंड फाइंड द वैल्यू ऑफ y. सिंपल. y is equal to 4h upon L square into x. X is equal to how much? L by 4. Multiply by L minus L by 4. Just solve it, you will get the answer. You will get the answer. So this value is equal to how much? 3L by 4 multiply by L by 4 multiply by 4H by L square. We can cancel L to L. Again, one more L can cancel over here. 4 to 4. So we will get a result over here, which is 3H by 4 as a Y. Y की वैल्यू कितनी आ गई? 3H by 4. So which one is the correct answer? कुछ बच्चे तो B बोल रहे हैं यार. यहाँ पे तो आंसर ही D है. बच्चे तो B बोल रहे हैं, आंसर ही तो D है ये. If you like the session, please hit the like button. है ना? अरे आंसर तो D है बच्चों. आप लोग तो B बोल रहे हो. Answer is D. 3/4 times of rise of the crown, which is known as central rise. इसे कई बार बच्चों हम लोग central rise भी बोल देते हैं. Central rise. Yes, Nathan, D होगा, है ना? Okay, so let's begin with the RCC part. Quickly give your answer for the RCC part. This is the first question of RCC. A rectangular beam is there whose width is given to us 250 mm and the effective depth is equal to 317 mm. grade of concrete is M20, grade of steel is Fe415. As per limit state method, the area of steel in the balance section is equal to how much? अब यार ये तो बहुत आसान क्वेश्चन है. I think you are able to solve this one. सभी लोग solve कर सकते हैं. We know that guys, for the balance section we can write C force is equal to how much? T force. Simple. What is your C force? C force is equal to 0.36 FCK B into XU limiting. Right? Why XU limiting? Because it is a balance section. This is our C force. It is equal to how much? T force, which is 0.87 Fy into AST. Right? Now just we have to find the value of AST over here. हमें AST का value find करना है. We can write it 0.36 FCK B into XU limiting divided by 0.87 Fy. बस ये करना है बच्चों, और कुछ नहीं करना. Right? So let's put all the values over here. 0.36. What is the grade of concrete? It is M20. तो FCK का वैल्यू कितना हो गया? M20. तो यहां पे 20 लिखेंगे बच्चों. What is the value of B, which is 250 given to us? What is the value of XU limiting? Now, as per the question, guys, you have to use Fe415, and we know that what is the value of XU limiting in case of Fe415? It is 0.48 times of D. So 0.48 into D. D is equal to how much? Effective depth. That is 317. Let's put this value and just calculate it. How much it is? It is 152.16 mm. Right? Let's put this value 152.16 divided by 0.87 Fy. अब बचा ही क्या इसमें? I think all of you are able to understand. Tell me guys. फटाफट बच्चे लोग जल्दी से कमेंट में लिख के बताओ, समझ में आ गया क्या? All of you are able to understand this question or not? We are getting a value of 758.58 mm square. So we can take the closest one, which is 757. 757. ए लगा सकते हैं यार, कितना आसान क्वेश्चन था. We can take the A option over here, which is a very, very simple one. Right? A is the correct answer. 757 mm square. ठीक है, चलिए आगे बढ़े. आइए आगे बढ़ते हैं बच्चों नेक्स्ट क्वेश्चन पे फटाफट. इन एन अंडर रेनफोर्स कंक्रीट बीम. अब तो यार सभी लोग आंसर देंगे. आई थिंक सभी लोग आंसर देंगे. प्लीज give the answer guys, all of you. For an under reinforced concrete beam, the actual depth of neutral axis is less than the critical one and the moment of resistance is less than the balance section. The C option is both are correct. D option none of this. Tell me guys. Quickly write in the comment box and tell me which particular option is correct over here. A, B, C or D. कौन सा ऑप्शन सही है? Write in the comment box all of you quickly. For under reinforced section, अंडर रेनफोर्स की बात तो बड़ी सिंपल होती है बच्चों. आई थिंक सभी को पता होता है कि अंडर रेनफोर्स कंडीशन पे क्या होता है जी. चलिए बच्चों मैं बताता हूं इसको. अंडर रेनफोर्स सेक्शन, यू नो दैट in case of under reinforced section, the actual depth of neutral axis is always less than the critical depth of neutral axis. है ना, ये पता होगा बच्चों. Let us suppose this is your limiting depth or critical depth of neutral axis. And let us consider this one is actual depth of neutral axis. किशोर बोल रहे हैं सर C होगा. Okay, you can see here guys, you can see here, this is our actual depth of neutral axis, which is XA. Now we know that in case of under reinforced section, your XA is always less than XC, right? This is the first condition by which we can say that our steel will fail first over here, and that particular failure is ductile failure. कैसा failure होता है बच्चों? Ductile failure है. You can write this one also, or you can write in this way also guys, which is XU is less than XU limiting. Generally we are writing this particular term in this particular way in LSM method, and it is written in this way in WSM1. So you can write in any one of them, no problem. So A is the correct one, and the MR value is less than the balance section. Yes, it is correct. Whenever you are finding the MR value for under reinforced, it is always less than the MR value of limiting section, right? So guys, B is also correct. So C is the correct answer. C सही होगा. सुमित भी बोल रहे हैं C होगा सर. सुरजार भी बोल रहे हैं C होगा. किशोर भी बोल रहे हैं C होगा. बहुत बढ़िया बच्चों. नेक्स्ट क्वेश्चन. नेक्स्ट क्वेश्चन. इट इज बेस्ड ऑन योर प्री स्ट्रेस कॉन्क्रीट, है ना जी. PSC पे बेस्ड है. इट इज बेस्ड ऑन PSC. An ordinary mild steel bar has been pre-stressed to working stress of 200 megapascal. Young's modulus of steel is 200 gigapascal, right? The permanent negative strain due to shrinkage and creep is 0.0008. Then how much is the effective stress left in the steel? कितना effective stress steel में बचेगा? ये क्वेश्चन है बच्चों. How much effective stress is to be left in the steel after the loss of pre-stress due to the permanent negative strain due to the shrinkage as well as your creep condition? Now first of all, you have to calculate the loss of stress. How much stress is to be lost over here? So can I say that how much strain is to be lost over here guys? Which is equal to 0.0008. This is the strain which we have lost over here. ये particular strain जो है बच्चों वो हमारा loss हो गया है. And we can divide it by Young's modulus of elasticity of the steel, which is 200 gigapascal. So you can convert it 200 into 10 raised to power 3, है ना जी. यहाँ पे हम क्या लिख सकते हैं? Let me write in this way. This is the loss of strain, है ना, and this is the ES value, which is 200 into 10 raised to power 3 megapascal, right? 200 into 10 raised to power 3 megapascal. Now just calculate the loss of strain, loss of stress, not the strain. हम stress को calculate कर लेते हैं बच्चों directly. How we can calculate the loss of stress? We know that stress upon strain is equal to how much? क्या लिखते हैं बच्चों? देख लो यार. Generally आप लोग क्या लिखते हो? Stress upon strain is equal to how much? E. So can I say that the stress can be written as strain into E value. So we can write this particular stress in terms of loss of stress is equal to loss of strain multiplied by ES. Simple. So 0.0008 multiplied by 200 multiplied by 10 raised to power 3. Just calculate this value. You will get the amount of loss of stress. कितना लॉस होगा जी ये आपको मिल जाएगा. It is 160 megapascal. We know that the unit of ES is megapascal over here, है ना, megapascal में रखा है, and there is no dimension of strain. So this particular value is 160 megapascal, which is loss. Now how much quantity of effective stress is to be left in the steel? So this is the loss, and what is the original value? It is 200 megapascal. So can I say that guys, the effective stress which is to be left in the steel is 200 minus 160, and it is equal to 40 megapascal. So C is the correct answer. कौन सा आंसर हो गया जी? C is the correct answer. C सही है एकदम, है ना. Next question guys. Next question. if the tendon is placed at an eccentricity E below the centroidal axis of the longitudinal axis of a rectangular beam in which the section modulus is given to us, whose value is equal to Z, and the stress load P is in tendon, the stress at the extreme top H, तो जार बोलने से C होगा, नो डाउट C है। तो आपसे पूछा गया है बच्चों, they want to ask you the stress at the extreme top edge is to be increased or decreased or it is unchanged, ये पूछा है। Guys, we know that we can eliminate two option over here. यहाँ पे हम दो ऑप्शन रिमूव कर सकते हैं easily. First one is this one and the second one is this one. We know that guys, whenever you are changing the position of tendon, then definitely you may find the change in the stress, whether it is top fiber or whether it is your bottom fiber. So D is the wrong answer, and also the dimension is incorrect in option number A. Why? Because you know that guys, generally we have to write this particular equation in this way. I think आप लोगों ने ये पढ़ा होगा बच्चों, sigma by y is equal to what? M by I. ये सुना होगा बच्चों, and we can say that guys, what is moment? That is our P into E, है ना, ये होता है, and what is the value of stress? So can I write it guys, P E y by I. Now what is the value of I by y? That is your section modulus, so we can write it P E by Z. So this is the dimensionally correct and it is dimensionally wrong, right? ये dimensionally wrong है जी। सुमित बोल रहे हैं सर C होगा, किशोर बोल रहे हैं D होगा। अब देख लो यार बच्चों, अब आपको समझ में आ गया होगा, है ना। अब इसको हम सॉल्व कर लेते हैं, बट अगर मैं आपकी जगह होता तो मैं सॉल्व नहीं करता। आई विल ट्राई टू सॉल्व दिस प्रॉब्लम डायरेक्टली without writing anything, but let me tell you guys how to solve it. This is your centroidal axis and your tendon is to be placed with an eccentricity of E below your centroidal axis. It means this particular eccentricity is E and there is some force which is P over here, right? Now we know that guys, at the top fiber we have two effect, दो effect होंगे। First one is compression which is P by A and second one is bending. So due to bending at the top fiber you may find the tension, और bending किसके कारण बच्चों? That is your PE, that is your moment, right? So minus PE by Z. This is the stress which may develop due to the bending moment due to the pre-stressing force at the top fiber. So our value get decreased by PE by Z. So C is the correct answer. C सही है जी, है ना। Next question guys, next question. Please hit the like button as well as share the session guys and tell me which one is the correct answer for this particular question. If the depth of actual neutral axis of a doubly reinforced beam, अब आपसे पूछा है बच्चों, एक doubly reinforced beam है and the depth of actual neutral axis, first statement, is greater than the critical depth of neutral axis, then concrete attains its maximum stress earlier. It means as per the first statement, XU is greater than XU limiting, then our section is what? Over reinforced. ये कैसा section होता है बच्चों? Over reinforced section होता है, and in case of over reinforced section, concrete will fail first, and that's why your concrete will achieve the maximum stress earlier. So A is the correct answer. A तो सही होगा जी, है ना। Next statement, the concrete attain its maximum stress earlier, ये तो हमें समझ में आ गया बच्चों, पहला statement. Next, if the depth of actual neutral axis of the doubly reinforced beam is less than the depth of critical neutral axis, it means XU is less than XU limiting. The steel in the tensile zone attain its maximum stress earlier. क्या ऐसा होगा? Yes, because it is under reinforced section. कैसा section है बच्चों? Under reinforced section. And in case of under reinforced section, your steel will try to attain earlier as a maximum stress, right? So steel will fail first. So B is the correct answer. B भी सही होगा बच्चों. Now what about D1? It is equal to the depth of critical neutral axis. Concrete and steel attain their maximum stress simultaneously. Yes, they get failed simultaneously. So C is also correct. It means this particular section is your limiting section. So A, B are C and A, B, C are correct. So D is the correct answer. All. बहुत शानदार बच्चों. All. Next question. The rectangular beam of width 250 mm is having an effective depth of 317. Width is 250. Effective depth is 317. 250. Effective depth is 317 mm. Right? Now the grade of concrete is M20. Grade of concrete कितना है बच्चों? M20 दिया हुआ है. And grade of steel is Fe415. Now as per the limit state method, you have to find the lever arm. आपको lever arm बताना है बच्चों. Lever arm कितना होगा? Tell me guys. For the balance section, it is balance section. It means we have to find the lever arm value with axial limiting. Now you know that guys, we can write D minus 0.42 axial limiting, right? Now we know that guys, axial limiting can be written as how much? It is K times D. So what is the value of K? Let me tell you once again guys. 700 divided by 1100 plus 0.87 Fy. And what is the value of Fy? It is 415. If you put this particular value, you may get this particular term as a 0.48 times D, right? So just put the value of axial limiting as 0.48 D. So can I write it guys? 0.48 times of D. D is equal to how much? It is 317. So 317 minus 0.42 times of 0.48 times of 317. Solve it, you will get the answer. But I will tell you the short trick also. You can solve directly. If you remember some values, standard values, then you can solve this particular problem directly, right? Let me tell you how it is possible. This is 253.09 mm. So we can say that guys, D is the correct answer. We know that guys, most of the time in the examination, D. Okay, yes, abhi D answer hai. Now you know that guys, most of the time you have to use the M20 grade and Fe415. Generally बच्चों हम लोग क्या करते हैं? M20 and Fe415 use करते हैं. So please remember this particular standard value, which is mostly used in your question, objective question. Do not try to solve such type of thing in your examination by using calculator, right? Just skip it. You can remember this value directly, right? If you put the value of K for Fe415, then it is equal to 0.48. We know that guys, there is some lever arm over here, and lever arm can be written as D minus 0.42 K times of D. So again you can take the common value as a D over here, 1 minus 0.42 times of K, and this is nothing as this is our lever arm draft factor, which is equal to J, and J into D. This is the direct formula to calculate the lever arm, है ना जी? और आप जानते हैं J की वैल्यू कितनी है जी? J की वैल्यू कितनी होगी? If you put the value of K over here as a 0.48, you may find this particular value is a 0.8. इसको put करो 0.48 को, you will get 0.8 over here. So if you put 0.8 into 317, you will get the answer, which is again 253.6. Simple. So just remember the values directly. It is very very useful for your examination, है ना? ये ध्यान रखें बच्चों. Next question. The factored load carrying capacity of a column whose size is 300 mm, 600 mm with minimum percentage of steel for M20 and Fe415 grade is equal to how much? अब बताओ बच्चों, अब मजा आएगा जी आंसर में निकालने में. Now tell me the answer for this question, because it is a very very good question for the column. You have to just find the load carrying capacity of your column with respect to this size and minimum percentage of steel. Minimum percentage of steel provide करते हुए आपको बताना है कितना होगा जी आपका load carrying capacity. Tell me guys, क्या होगा? Just tell me which one is the correct answer over here. इनमें से कौन सा आंसर सही है? Just solve it and let me know guys which one is the correct answer. Can you tell me what will be the value of minimum percentage of steel in the column? मिनिमम परसेंटेज स्टील कॉलम के अंदर कितना होता है? एनी वन ऑफ यू? इफ यू नो दैट पर्टिकुलर वैल्यू देन ओनली यू आर एबल टू सॉल्व दिस वन. अगर वो वैल्यू पता होगा ना बच्चों तो ही सॉल्व कर पाएंगे, अदरवाइज वी आर नॉट एबल टू सॉल्व दिस. बताएं 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 बच्चों बताएं. सुमित, किशोर, सुरजार, नितांत, वर्षा, असिम, टेल मी गाइस. 0.6% बोल रहे हैं शिवम, 0.6 बोल रहे हैं. अच्छा, एनी अदर स्टूडेंट? गुड इवनिंग राम, आते जाए बच्चे. जस्ट टेल मी गाइस व्हाट इज द वैल्यू ऑफ मिनिमम परसेंटेज ऑफ स्टील इन केस ऑफ कॉलम. मिनिमम परसेंटेज ऑफ स्टील दैट इज 0.8. वेरी गुड सुमित. सुमित वेरी वेरी गुड, दैट इज 0.8% यार. 0.8% as a minimum value. 0.8% as a minimum value. Now you know the formula guys, how to calculate the factored value of load carrying capacity of column. That is equal to 0.4 FCK into AC plus 0.67 FY into ASC. यही होता है बच्चों, right? Now we know that guys, what is the minimum percentage of steel? That is 0.8%. Now let us suppose guys, if you have a cross section over here, आपके पास एक cross section है यार, है ना? Let us suppose the overall cross section of this particular column is B cross D, right? So can I write it? The area is equal to how much? It is B cross D, which is equal to how much? 300 cross 600. Now we know that guys, our area of steel is 0.8% of this particular area, right? So ASC can be written as 0.8% of 300 cross 600. You can calculate this particular area of steel. ये निकाल सकते हैं बच्चों आप लोग, कुछ भी नहीं है इसके अंदर. It is 1440 mm square, right? And whatever remaining area is to be there, that is for concrete. So can I write it? AC is equal to how much? AC is equal to 99.2% of the overall cross section area. यही होगा. The remaining value is to be like this one. 99.2 multiplied by 300 multiplied by 600 divided by 100. How much it is? 178,560 mm square, right? Let's put all the values over here. 0.4 FCK, that is 20. AC 178,560 plus 0.67 FY 415, ASC 1440, bracket close, just multiply with 10 raised to power minus 3. You will get the answer in kilonewton. kilonewton में आंसर मिल जाएगा बच्चों. I think all of you know this particular formula. आप सभी को ये फॉर्मूला पता होगा बच्चों पहले से, because generally it is to be used to design the short column. Yes, we are getting some value over here, which is 1828.872 kilonewton, and we can write it. It is approximately equal to 1289 kilonewton. So C is the correct answer. कौन सा आंसर हो गया जी? C is the correct answer. C is the correct answer, right? Next question, guys. Next question. Next question. Next question. We have 3 question left. हमारे पास बस 3 question है बच्चों. फटाफट solve करेंगे. Then we will close this lecture, and we will meet tomorrow for a new session of environmental engineering and engineering mechanics. Tomorrow I will bring the questions of environment and the engineering mechanics for your BARC and ISRO as well as AAI. So be ready at 10 PM daily, guys, right? So we will cover these type of problem in the upcoming session, है ना? जो environment के होंगे और mechanics के होंगे वो हम कल cover करेंगे, ठीक है? Tell me the answer for this question. A simply supported pre-stressed concrete beam is to be there, whose dimension is 300 cross 500 mm. In cross section and is subjected to a superimposed load of 2T 20 kilonewton per meter over a span of 10 meter. If pre-stressing force is to be 1000 kilonewton applied through a straight tendon located along the centroidal axis, then what is the extreme top fiber stress at the mid span? I think it is a very simple one. बहुत सिंपल होने वाला है बच्चों ये तो. We know that guys, we have to put the tendon at the centroidal axis, along the centroidal axis, and we know that there is one pre-stressing force which is to be applied, that is equal to 1000 kilonewton, right? Now we know that guys, we have some external loading as a UDL whose value is equal to 20 kilonewton per meter, right? Just you have to find the value of stress at the top fiber. Top fiber में पता करना है बच्चों. So can I say that guys, at the top fiber, due to this particular pre-stressing force, we have a compression over here whose value is equal to how much? P by A. And the second value is bending moment. And we know that what is the bending moment diagram at the center? What is the bending moment diagram over here? It is to be like this. And the bending moment value at the center of span is equal to how much? WL square by 8. So just put this value. What is the value of W? 20. What is the value of L? That is 10. 10 square divided by 8. Just calculate the bending moment over here. Bending moment calculate करिए बच्चों कितना आया? It is equal to 250. कितना? 250 kilonewton meter. Right? Now we know that guys, due to this particular loading, we may find the compression force over here at the top fiber, and that particular value is equal to how much? M by Z. Simple. M by Z. M by Z. Now let's put all the values over here, which is 1000 kilonewton. So just convert this kilonewton into the Newton one. So we can write 10 raised to power 3 divided by cross section area, which is 300 cross 500, plus what is the value of moment? That is 250. So 250 into 10 raised to power how much? 6 divided by section modulus. So guys, what is the value of section modulus? We know that the moment of inertia is BD cube by 12. Let us suppose this one is D and this one is B. So what is the moment of inertia? It is BD cube by 12. But if we want to find the section modulus, it is BD square by 6. Because we have to divide this particular value with y, and y is equal to how much? D by 2. है ना जी? ये होता है बच्चों. So let's put this value BD square by 6. So B is equal to how much? It is 300. D is equal to how much? It is 500 square divided by how much? 6. Just calculate it. You will get the answer. 1000 divided by 300, 500. Okay. We are getting a value of 6.67. The first value, and the second value 250 into 10 raised to power 6 multiplied by 6 divided by 300 and 500 square. How much it is? It is 20, right? Just add both the values, you will get 26.67 megapascal as the answer. So B is the correct answer. हाँ, plus क्यों हुआ? That is a very good question. Just listen carefully. सुमित ने बहुत अच्छा क्वेश्चन पूछा, सर प्लस क्यों हुआ? You can see here guys, due to this particular pre-stressing force, you may find the compression at the top as well as compression at the bottom. Whatever compression force is there in case of pre-stressed concrete, we have to consider as a positive, right? Now you know that guys, there is some loading at the top fiber, which is trying to create the bending moment, है ना? Bending moment create कर रहा है. At the top fiber, you may find the compression, and due to the compression one, this particular value is to be positive. और ये स्ट्रेस जो आ रहा है ड्यू टू बेंडिंग, वो उसी के कारण बच्चों पॉजिटिवली आ गया है. सुमित, अंडरस्टूड? लेट मी शो यू वन डायग्राम. अरे यार, ये P बाय A के कारण आपके पास एक तो स्ट्रेस ये होगा ना बच्चे. दिस इज द फर्स्ट स्ट्रेस विच इज पॉजिटिव एट द बॉटम एज वेल एज पॉजिटिव एट द टॉप, दैट इज P बाय A. एंड द सेकंड वन इज ड्यू टू बेंडिंग मोमेंट. Due to bending moment at the top, you may find the compression, but at the bottom, you may find the tension. And whose value is equal to how much? M by Z. Right? So that's why guys, this particular value is to be added at the top fiber. ये यहां पर ऐड हो जाएगा एंड यू हैव टू सब्ट्रैक्ट फॉर द बॉटम वन, है ना? आई थिंक सुमित नाउ इट इज क्लियर। नेक्स्ट क्वेश्चन गाइस, जस्ट हिट द लाइक बटन, ऑल ऑफ यू, सभी लोग हिट करेंगे भाई लाइक बटन को। टेल मी गाइस, द डेवलपमेंट लेंथ ऑफ अ डिफॉर्म्ड reinforcement on the compression reinforcement can be expressed as this. For the IS code 456-2000, the value of K is equal to how much? The value of K is equal to how much? Do you know what is the development length value? It is generally written as 0.87 Fy into phi upon how much? कितना लिखते हो जी? ये वैल्यूज आप लोग कितनी लिखते हो? 4 times tau bd, याद है क्या बच्चों? And this particular value is equal to how much? Tau bd is what? Developed or permissible? It is permissible. Permissible. ये लिखते हो बच्चों? Now just tell me what will be the value of K for this particular condition? Because we have deformed bar. In case of deformed bar, this particular permissible value is to be increased by 60%, and for the compression one, it is also increased by 25%. है ना जी? तो ये जो tau bd permissible है, it is to be given for mild steel and tension reinforcement. But we know that guys, we have deformed bar, which is HYSD. So our value get increased by 60%, and this particular reinforcement is in compression. So you have to again increase that particular value by 25%. So this particular value, which is tau bd permissible, get modified over here and can be written as 1.25 times 1.6 times of tau bd permissible. ये हो जाएगा जी. Now let's calculate the value of LD. 0.87 Fy into phi upon 4 into 1.25 into 1.6 tau bd. Just calculate the value of K. 4 into 1.25 into 1.6 divided by 0.87. So how much it is? It is equal to 1 by 9.195 multiplied by Fy into phi divided by tau bd permissible. Now the value of K can be equal to C, है ना जी? C के बराबर होगा बच्चों. बड़ा मजेदार क्वेश्चन है बच्चों. ऐसे क्वेश्चंस आपको मिलेंगे आपके एग्जाम के अंदर, right? You may find these type of question in your examination. Now let's move to the last question of the session. Last question पे बढ़ते हैं बच्चों, and tell me the answer of this one. देखते हैं ये वाले कितने बच्चे आंसर दे पाते हैं. I think ये तो सभी को पता होता है भाई. This is the last question. This is the last question of session, guys. And tell me, the design bending moment for the limit state of collapse is equal to how much? The design bending moment for the limit state of collapse is equal to how much? ये बताना है बच्चों आपको. Please remember, guys, from tomorrow or on tomorrow we will cover the environmental engineering and engineering mechanics at 10 p.m. on the same Gradeup YouTube channel, right? At 10 p.m. Please join this session. You will get the benefit, right? And if you want to come on the FE class, you can join the FE class tomorrow at 5 p.m. So tomorrow I will discuss small things, how to use the small approach to get the big success, है ना जी? छोटी छोटी अप्रोच से बड़ी सक्सेस कैसे पाए, ये कल मैं आपको बताने वाला हूँ 5 बजे FE क्लास के अंदर. तो आइएगा बच्चों on Gradeup FE class at 5 p.m. tomorrow. Anyone who know the answer for this question? कोई भी बच्चा इसका जो आंसर जानता हो? Anyone? चलिए मैं बता देता हूं बच्चों. Now we know that dead load is equal to how much? 20 kilonewton meter. Live load is 30 kilonewton meter. And the seismic load moment is 10 kilonewton meter. These are the moments value which is given on the basis of different kind of loading. Now just we have to calculate the design bending moment over here. But listen carefully, we can make different kind of combination over here. Like you can make a combination of dead load plus live load. You can make the combination of dead load plus live load plus seismic load, which is known as earthquake load. So guys, we have two type of combination, but in these two type of combination, we have different factor of safety. For this one, we have 1.5. For this one, we have 1.2 only. So let's calculate the value for this one, which is 1.5, bracket dead load as 20 and the live load as a 30. So we will get a value of 75 kilonewton meter. Now the next combination is 1.2, 20 plus 30 plus 10, and if you solve this one, you will get 72 kilonewton meter. So which one is critical, 75 or 72? 75 is critical, guys. And this is the trick, which is, or this is the यही जो लोचा था बच्चों, जो आपको समझ में नहीं आया था, right? This is the problem in which lot of students are trying to take the option number C, which is 72 kilonewton. ये सब लोग टेक करते हैं बच्चों, और यही गलती करते हैं because we have to take care of different combination over here and just try to find which one is more critical. If you design this particular condition, then it means it is safer in this condition as well as this condition. We know that the seismic load is not present for the continuous or for the design life of the structure. क्या पूरे के पूरे हमेशा डिजाइन लाइफ तक seismic load होगा? No, right? It is only for a certain duration, and which is very less duration, I think. So that's why, guys, we can see here this particular bending moment is 72 and this value is 75. So this one is very critical. If we design our structure for this one, then it is safer, and this one is also safer. But if we design this particular structure for 72 kilonewton meter, then it may collapse at this particular loading condition. और यही clue था जी, right? So B is the correct answer. B सही आंसर है. And if you like this session, guys, अगर मजा आया हो क्वेश्चन सॉल्व करने में, प्लीज हिट द लाइक बटन एज वेल एज शेयर द सेशन, है ना? अगर मजा आ गया हो बच्चों, तो आप लोग शेयर भी करेंगे और इसे लाइक भी करेंगे सेशन को. और कल 10 बजे आप लोगों को मिलना है ग्रेडअप यूट्यूब चैनल पे, यहीं पे बच्चों, जहां पर हम और भी क्वेश्चंस की बात करेंगे, राइट? सो जस्ट पुट द लाइक बटन ओवर हियर, गाइस. एक बार लाइक बटन दबा दीजिए फटाफट. अगर सेशन आपको पसंद आया हो, कमेंट बॉक्स में छोड़ दीजिए, ठीक है? ओके सर, अंडरस्टूड. ओके कार्तिका, चलिए. सो जल्दी से लाइक बटन दबा देंगे बच्चों, फटाफट लाइक बटन दबा देंगे सभी लोग. और अगर मजा आया हो बच्चों सेशन में, तो वाई या एन लिख देंगे कमेंट बॉक्स में. मजा आया हो सेशन में तो वाई या एन लिख देंगे जी, यस और नो. Okay, so if you want to join our Gradeup Super platform, guys, you can join us on Gradeup Super, in which we will discuss the concept as well as your courses for GATE and EAC in full detail. So you will get the 950 plus live hour classes, as well as 10,000 plus practice questions, as well as 100 plus mock tests and 120 plus chapter wise study notes, right? If you want to join, you can contact on this number. Similarly, guys, you can see here there are various faculty over here like Abhinav sir, Ankit sir, Ansari sir, Rohan sir, me, Anirudh, and Joshit sir. So guys, definitely you can learn the concept from star faculties, है ना? आप star faculty से पढ़ सकते हैं बच्चों, and you will definitely achieve some rank on your GATE and EAC. अगर आप लोग बच्चों पढ़ते हैं, no doubt मेहनत करते हैं, it doesn't matter whether you are joining us or any other platform, but definitely if you work hard, you can achieve your dream. अगर आप लोग अपनी मेहनत बहुत करते हैं ना बच्चों, तो definitely you can achieve your dream, right? मजा आ गया सर. Okay, thank you. So guys, you will get in the Gradeup Super platform the structure live course over here, and which is conducted by your India best faculty team. Complete dot resolution, full syllabus coverage, as well as you will get the green card for Gradeup Super, right? And in which you will get the online mock test, as well as which is designed by topper and based on latest pattern of examination. So guys, this is all about for today. आज के लिए इतना ही, मगर कल हम बच्चों मिलेंगे 10 बजे वापस से, and tomorrow we will deal with a very interesting topic, that is your environmental engineering and engineering mechanics. मजा आ जाएगा जी, कल बिल्कुल मिलेंगे और शानदार तरीके से लिखेंगे, है ना? चलिए जी, just revise your concept for environmental and mechanics, and कम टुमारो गाइस एंड लेट्स सी कितने प्रॉब्लम आप सॉल्व कर पाते हैं. चैलेंज योरसेल्फ. सो थैंक यू सो मच फॉर ज्वाइनिंग द सेशन. गुड नाइट टू ऑल ऑफ यू. आप सभी को गुड नाइट, शुभ रात्रि. और होप सो आप लोगों को पसंद आया बच्चों सेशन, है ना. चलिए क्लोज करते हैं. बाय बाय, गुड डे एंड टेक केयर. गुड नाइट बच्चों, गुड नाइट, गुड नाइट.